Alrighty guys, we're continuing on with our exponential equations, starting with number 9. Here we go. Number 9, 3 to the negative x equals to 30. And we're going to do the usual thing, hit it with the logs on both sides. I got negative x, natural log of 3 is equal to the natural log of 30. Divide by natural log of 3, I got negative x equals to natural log of 30 over natural log of 3. And then get rid of this negative, multiply both sides by -1 or divide by -1, whichever you like. And I'm going to get positive x equals to negative natural log of 30 over natural log of 3. That negative can go up top or bottom or in the middle, but I think it's more, to me it's more easier to understand if you put it just at the top or the bottom. Because otherwise you're going to confuse yourself with whether you should put it at the top or bottom when you punch it into your calculator. So I'm going to punch this in negative log 30 divided by natural log of 3 in my calculator off screen. And I get x is approximately, so this is the exact answer, right? Approximate answer is negative 3.095. But that's going to round to negative 3.10 to the nearest 2 decimal places. Now, as you're doing these things, you can do a quick check, and you could actually plug it in back into your calculator. 3 to the negative, whatever your answer was, 3 to the negative, that's 3 to the positive 3. And you can also do a quick check just to make sure that makes sense. So think about it this way. If I plug in negative 3 for x, it's going to take a negative of that, so it's going to be 3 to the positive 3.1. And I know 3 to the 3 is 27, so it makes sense 3 to the 3.1 would be about 30. So that answer does make sense. In a test situation, I'm not going to necessarily do this for every question, but in a test situation, it does make sense to do that just to make sure that you didn't make a careless mistake somewhere along the way. Make sure that your solution actually does, in fact, work, if you have the time for it anyway. Okay, question 10 is 10 to the x, negative x plus 3 is equal to 102. And this is an interesting question because here, see the base is 10, and we know one of our two options, natural log and the common log, has a base of 10. So I'm going to hit it with that particular log and see what happens. So log base 10, right? Log base 10. Now when you see it in the calculator, it's just written as log of this thing. On the left, it's going to actually undo it. It's going to undo this thing. It's an inverse because it's got the same base. If you don't see that, it's okay. Watch what happens if I didn't see it. It's going to be just negative x plus 3. This would be log of 10, right? But what's log of 10? Well, this is 10 to the log base 10 of 10. 10 to the what is equal to 10? The answer is 1. So this whole thing just becomes a 1. See that? And here is this log base 10 of 102. Okay. I didn't really need these parentheses here because I'm only multiplying by 1 on the left, right? So let's just get rid of those. And how do you solve that? Subtract 3 on both sides. Negative x is equal to log base 10 of 102 minus 3. And then I get rid of this negative by multiplying everything by -1. So x is going to be equal to negative log base 10 of 102 plus 3. So here's your exact answer. Let's get an approximation now. Negative log of 102 plus 3. Okay, and I got the answer is 0.991, and that's about 0.99. Okay, let's just check real quick. Does that make sense? Negative x here would be about -1, so you're roughly at 10 to the 2, and 10 squared is 100, and that's about right. So yeah, that does make sense. Okay, not exactly 100, but this is not exactly 1. Okay, 11. 25 equals to 10 to the negative 2x. So again, you got this base of 10, right? So it makes sense that I'm going to hit it with the common log once more. So anytime you see, you don't have to. I could have actually hit it with the natural log and then still get an equivalent correct answer, just written in terms of natural logs. But since I've got the 10 base, might as well take advantage. Hit it with the log base 10, yeah? And the right side undoes it. Let me do the left side first. Left side is exactly what it is. Stays the same. Log base 10 of 25. Right side, these guys are inverses, so I'm going to just get the negative 2x, pop right out. And how do I solve this? Okay, well, I want x by itself, so divide by negative 2, right? So I got positive x is equal to log base 10 of 25 divided by negative 2. That's an exact answer. And let's now plug that thing in. Log base 10 of 25 divided by negative 2. Okay, and I get about negative 0.698. And to the nearest 2 decimal places, negative 0.70. Okay, once more, that makes sense, right? Does that make sense? Actually, I'm just going to do a quick check. 10 to the negative 10 raised to the negative 2 times 0.7. Wait a minute. Oh, no, it's a negative 0.7. So it's actually 10 raised to the 2 times 0.7. Yeah, that's right. About 25. And this is rounded, so it's not going to be exact. Okay, number 12. Let's see. Oh, I just realized I cut off the bottom question. That's okay. We'll deal with that when we get there. Number 12. 7 to the negative 3x squared equal to 9. Okay, same old approach. Hit it with the logs on both sides. I got negative 3x squared, natural log of 7 is equal to the natural log of 9. Okay, I want to get x squared by itself. So I'm going to divide by natural log of 7 first. That gives me negative 3x squared is equal to natural log of 9. You could combine 2 steps and divide by negative 3 natural log of 7 if you want. But I'm just doing it one at a time so I don't lose anybody. Divide by negative 3. X squared is natural log of 9 over negative 3 natural log of 7. Okay, well, this is x squared, but I want a regular old x, right? So what I do is square root both sides, and I'm going to get x is equal to, make sure that you include here the plus or minus, because I got 2 possibilities, right? Plus or minus the square root of this thing. Natural log of 9 over negative 3 natural log of 7. Okay, so here's your exact answer. Now let's punch this thing in and see what happens. Natural log of 9 divided by parentheses, yeah? When you punch it into your calculator, add a set of parentheses here. Negative 3 times the natural log of 7, and then close your parentheses. And here's what I got. X equal to approximately, okay, plus or minus the square root of negative 3.764. I'm going to keep a couple extra digits here for now, actually. 387638. Okay, now here we have a little problem, right? I'm taking a square root of a negative. So if you're dealing only with real solutions, then you could stop here and say there's no solution, actually. And that this one here was actually not a solution either. But, you know, we've seen complex numbers before, so you can let's allow for complex numbers. If I allow for complex numbers, what happens is I'm going to take the square root of that answer, and let's just plug in the square root of the negative to get there. So what I mean by that is I'm going to take the square root of 3.7638. And I'm actually going to plug in more decimals looking at what I have stored in my calculator. So 0.3, I mean. Did I say, I put the decimal in the wrong spot. Sorry, guys. Should be right here. So I'm going to take the square root of 0.376383356. Okay, and it gives me x is approximately, when I take the square root, it gives me 0.613. So that's 0.61 to the nearest 2 decimal places. But this is a square root of a negative, right? So I want plus or minus 0.61i. That's what you got. Okay, now this one is one where I would like to check this. So how do I check this? Well, if I was to plug in 0.61i into this formula right there, that equation, then when I square it, I would end up getting 0.37638, but negative, right? So what I'm going to do is I'm going to plug in a negative 0.37638 times negative 3, this negative 3, and that's going to give me 1.129. Okay, now I'm going to raise 7 to that 1.129, and if it works, I should get 9, or approximately 9. 1.129. And I do, yeah. I get about 9. 8.99. And because I lost accuracy with the rounding, it's not exactly 9. Okay, so that worked. Okay, number 13. I said I wasn't going to check these, but I ended up checking all of them. So let me not check the next 3. Okay, we'll just do the work and trust that we did it correctly. You can check me and get extra credit by finding my mistake later. E to the x plus 1 is equal to 10 to the negative 2. Hey, the interesting question, because here I got a base e and I got a base 10. So either choice I do, I'm going to get one of the inverse properties pop out, right? I take my pick. I'm going to use my typical ln, both sides. This side's the exact inverse, so I get x plus 1 on the left. The right-hand side, I got negative 2x times the natural log of 10. And now from here, I want to gather all my x's to one side. So I'm going to put them on the left side. I got x plus 2x natural log 10. Remember, this part's just a number. And this plus 1, I'm going to subtract on both sides, so I got minus 1 on the right. Now here, I'm going to factor out the x's. I got x here, I got x there. So it's going to be x times 1 plus 2 natural log 10. Yeah. So I just extracted this x. This is what's left over. And then this is negative 1 here. Okay, so now I divide that negative 1 by this thing to get my x by itself. Let's choose a different color here. That gives me x equal to negative 1 over 1 plus 2 natural log of 10. And that is our exact answer, it looks like. Now let's plug it in to get the approximation. When you plug it in, don't forget, keep your denominator with its own set of parentheses. 1 plus 2 times natural log of 10. Okay, and I got x as approximately negative 0.18 if I go to the nearest 2 decimal places. Okay, moving on. Okay, that was number 13 we just did. So now number 14. 6 to the x plus 1 equals 12 to the x. And the usual. Hit it with the natural logs. I've got x plus 1 times the natural log of 6 is equal to x times the natural log of 12. Now here, I have a x plus 1, so I want to get x's isolated. I'm going to end up just multiplying that thing out, foiling it basically. And that gives me x natural log of 6 plus just a 1 natural log of 6, or natural log of 6. Now here's a big step. I'm going to move everything that has an x to one side. So move all those guys to the left. I got x. I guess it's not really a big step. But subtract both sides by that thing. X natural log of 12, right? I just subtracted by that. And then meanwhile, this one, I'm going to move it to the right by subtracting it on both sides. So I subtract on the left, it's gone. Subtract on the right, I got negative natural log of 6. Okay, now, got an x there, got an x there. Let's factor that sucker out. I got natural log of 6. Sorry, that looked like a 0. Natural log of 6 minus natural log of 12 equals negative. Just rewriting this thing, negative natural log of 6. And then last step, divide by this whole big thing in parentheses. So it's x equal to negative natural log of 6 divided by the natural log of 6 minus the natural log of 12. So here's my exact answer. And let's get our approximation by punching that in. Negative natural log of 6 divided by parentheses natural log of 6 minus the natural log of 12. Okay, and I get x is about 2.58. So there you go. Okay, last one, and this part of the problem got cut off, but that's okay. I'm gonna copy it down again anyways, and I can see enough of it to gather what it was. Let's do this thing. 15. I've got 4 times 2 to the x minus 5 is equal to 3 e to the x plus 1. Okay, off the bat, it looks like it's kind of ugly, but here what I like to do is first do a little simplification so that I can actually hit it with the logs. Actually, no, wait, let me take that back. Take that back. I'm just gonna go ahead and hit it with the logs right away. Just gonna log it both sides. Or do I want to do that? Let me think again. Actually, maybe it's better if I combine some numbers a little bit first to consolidate a bit. Yeah, let's consolidate a bit. So by consolidate, what I mean is let's at least get these two multipliers combined first. So what I'm going to do is I'm going to divide both sides by 3. Why did I do that? It's not necessary, not strictly speaking necessary, but it just makes it a little cleaner, I think, in the next step. Okay, so all I did is that. Just divide both sides by 3. Basically, I have the same equation. Now I'm going to go ahead and hit it with the logs on both sides. So natural log on this side, natural log on this side. And nice thing that happens on the right side, I'm going to do that first because this is an exact inverse, right? Natural log and e, those are, natural log means it's the base e. So those guys undo each other perfectly, and I just get x plus 1. That's pretty. On the left side, not as pretty. But what you notice here is you've got a natural log of things that are multiplied, right? And our rules of natural logs, or logs in general, say that if I have a log of something multiplied, I can separate that into log of 2 things that are added. So this is log of 4/3 plus the log of 2 to the x minus 5. Okay, now we're getting somewhere. So here, this is just a number. This guy is what we're used to dealing with, right? So let me just do this step by step so I'm not going to lose anybody. This guy, I'm going to pull that exponent down to earth because that's what I can do with logs, right? It says exponents become multipliers. So I got natural log of 2 times x minus 5. And on the right side, x plus 1. Okay, now what I'm going to do is move everything that has an x to the left, everything that doesn't to the right. Here, this guy has got to actually multiply out first, though. So I was getting ahead of myself. I got to distribute this thing first. So I got natural log of 4/3 plus x, natural log of 2, minus 5 natural log of 2. That's equal to x plus 1. Okay, now let's look for our x's. So this guy has an x, and that's an x exactly. So let's move those guys to the left. So I've got x natural log of 2 minus x. Okay, now let's deal with everything else. So I've got natural log of 4/3 minus natural log of minus 5 natural log of 2 and a positive 1. But I want to move those to the right side. To do that, I'm going to subtract this guy and add that guy. So I'm going to get 1 minus natural log of 4/3 plus 5 natural log of 2. Okay, and then on the left now, I want to get x by itself, right? So I'm going to factor out the x. Kind of a critical step here. Here, I'm just going to copy everything down. And then last step. To get x totally by itself, just divide by this second thing. So I got x equal to 1 minus natural log of 4/3 plus 5 natural log of 2, all divided by natural log of 2 minus 1, and keep that in parentheses. Okay, so here's my exact answer. Now let's get the decimal approximation for that thing. Yeah, that's when you're punching this into a calculator, because I've got pluses and minuses in the numerator, you have two options: punch this thing in first and press enter, or keep it in parentheses. Either option. I personally like to just hit enter once first. 1 minus natural log of 4/3 plus 5 times natural log of 2. Enter. And then the result, I divide by parentheses. Natural log of 2 minus 1. One other word of caution, guys. When I enter things into my calculator, the way my calculator is, and this might not be true for yours, but mine does this, where it automatically opens the parentheses. And if I don't close this parentheses and I start to write the next thing, then it'll do something like this funky. It'll do like this, which is not what I want, right? So you got to remember to close this parentheses before you do anything else, if your calculator is like mine. Just a small tip. Okay, and I got x is approximately negative 13.62. So that would be my final answer. Okay, guys, that's it. Hope that helped.